Okay? So, exactly as before, how do you calculate gradient? It's small m and capital AB. How do you calculate gradient? y2 minus y1 over x2 minus x1. You will be doing the gradient calculation so often that you will start memorizing the formula. Alright? We should be memorizing it. So if this is x1, y1, this has to be x2, y2. So it's going to be 2 minus 5 over 15 minus 12. 2 minus 5 is negative 3 over 3, which is negative 1. Okay? That's number 4.1. Did you look at 4.3? 4.2 is the same. Okay, as I said, it's going to do the odd numbers, so every alternate sum. Again, how do you calculate gradient of AB? y2 minus y1 over x2 minus x1. If that is x1, that will be y1, x2, y2. So it's going to be 7 minus 7 over negative 4 minus 2. You see there's a negative there by the 2. So this negative here is that negative there. Can you see that? And the negative from the 2 is from the number itself. You guys understand? So what happens now? That 7 minus 7 is 0 over minus 4 minus minus 2 become negative 4 plus 2, which is negative 2, which will give you answer 0 there. Again, gradient is 0, so what do we know? The 0 it will be parallel to the x-axis. Let's look at worksheet 15b. In worksheet 15b, the first question says, change each of the following to standard form. Then it says, sketch number 1 to 4 using the table method. So if you're going to use number 1, if I'm going to use the same. Okay, so let's look at number 1. So we got 3x plus 3y equals 9. Standard form. What is standard form? It must be in the form of y equals mx plus c. So how do I get it in that form? I take the 3x over. So 3y equals negative 3x plus 9. Now I divide by 3. So y is equal to negative 1x plus 3. Or negative x plus 3 is the same. So if you, this is the first part of the question. A. B. Sketch number 1 to 4 using the table method. So if you draw the table method, you choose a few values for x. So you go minus 2, minus 1, 0, 1, 2. Okay, you could have chosen any values. Okay, but importantly is to get that value there out, which is your y-intercept. Okay, which is to give you a nice idea of how your graph looks. If you had chosen other 3 values or 4 values, it's fine. Okay. So if I put negative 2, if I see an x, it's going to be negative times negative 2, which is positive 2 plus 3 is 5. Negative 1 times negative is going to be positive 1 plus 3 is 4. Put 0 in, 0, negative 0 plus 3 is 3. Put 1 in, negative 1 plus 3 is 2. Negative 2 plus 3 is 1. Okay. So what we do is, we plot these points. Okay. We plot these points. These over a bit. So we chose negative 2, negative 1, 1, 2, 3, or 1. So, okay, it's 1. So we have 1, 2, 3, 4, 5. Just by approximation, if you're not going to get this in that exam, we will give you a grid to work for. Okay? But just by approximation, this coordinate here now becomes negative 2 and 5. That coordinate is negative 1 and 4 and so on. You guys understand? So it's 1, 2, 3, 4, 5. So it's negative 2 and 5. Negative 1 and 4. 0 and 3. 1 and 2. 2 and 1. If I put 3 in, what am I going to get? 0. You see that? So if I draw this line with a ruler, you'll see that it will go through all of those points. Does that make sense? Is any confusion? Right, I'm going to do number 3 quickly. But I would need the space again. Number 3, the summary. 2 equals 3x minus 1. Make y the subject of your formula. So y is equal to 3x plus 2. It's in standard form now, not so? Before drawing the graph, what do we know about m here? What's your m value? It's 3. So what does that tell you about the graph itself? Increasing. What's your c value equal to? 2. And what does that tell us of the graph? That's your y-intercept there? 2. Not so? So, since they didn't tell us which values to use for the table, I'm going to choose my own values. Okay. I'm just going to go with, first draw the table. So x and y. I'm definitely going to choose 0. Let's go with minus 1 and minus 5. 1 and 5. Okay, 5 at least too big. Let's go with 0, minus 1, and plus 1. Let's go with 3 and minus 3. Okay. So if I put negative 3 into the equation, what do I get? What is 3 times negative 3? Negative 9 plus 2, negative 7. Put negative 1 in, I get negative 1. Put 0 in, I get 2. Put 1 in, I get 5. Put 3 in, I get 9 plus 2 is 11. This graph is going to be a bit longer or a bit bigger. Values that shows us minus 1, 0, 1, 2. But of course you're going to use a ruler to measure these values. Use the ruler to get the increments as happen. Okay? And then the minimum value, the smallest value is negative 7, so it's 1, 2, 3, 4, 5, 6, 7, negative 7. The maximum value is 11, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? That's the best I can do for now. Okay, so when I plot is negative 3 and negative 7. Did you see that? Negative 3 and negative 7. Then negative 1 and negative 1. What's up? 0 and 2. 1 and 5. There's 1, 2, 3, 4, 5. Okay? And then 3 and 11. You see that, people? And again, I take a ruler. I will be able to draw a line through here. If your graph was drawn on a Cartesian plane that is well measured out, then you will get a straight line going through. Does it make sense? Okay. Maybe in the next worksheet I will draw a what's the name, a proper axis of symmetry for you guys. Okay, with Cartesian plane. Alright, any confusion, people? Huh? No? Just remind me about if I can do a good drawing for you. But we're running out of time now. I just need to cover enough. Okay. Then in number 5, you see 5 to 7 is conforming to A and C now. Because that B was for question 1 and 1 to 4 only. So if you're looking at number 5, you get that in the standard form first. You've got 4x plus 2y equals 8. So what must we do? We must make y the subject of the formula. You've got 2y is equal to negative 4x plus 8. Now I divide by 2. So y is equal to negative 2x plus 4. You all okay with that? Alright. So the question says sketch number 5 to 7 using the intercept method. So what are they referring to there? That is your x in not C but B but C. How do you work out our x-intercept? Let y equal to 0. Not so. So there's your y. So 0 is equal to negative 2x plus 4. Now it becomes a simple equation. Not so. Why do we let y equal to 0 when you work out your x-intercept? Who can tell me? Why do we, for our x-intercept, that means to say with the graph is going to cut your x-axis. Why do we let y equal to 0? Yes? Not two unknowns, right? Not about that. Why do we let y equal to 0 when we work out the x-intercept? Huh? Because anywhere on the x-intercept, your y value is 0. Anywhere on your y-intercept, your x value is 0. That is the reason why. Okay? So we got y-intercept. What do you do for y-intercept? Let x equal to 0. Why do we let x equal to 0? Because yes, anywhere on the y-axis, x is equal to 0. Okay? So we put 0 where you see x now. So you got y is equal to negative 2 times 0 plus 4, which is 4. And this is enough information to draw the graph. So now we just do it by approximation, and that is the reason why many learners choose this. If they have a choice, they choose this method. It's easy. Okay? So x is 2, that is 0. 1, 2 is approximately there. And you have a y value of 4. There's 1, 2, 3, 4. I don't need the rest. I take a ruler and I draw the line. Going through 4 and 2. Does it make sense? Any confusion? Right. Let's do number 7 quickly. Number 7. Number 7, you've got x plus y equals 3. You take x over, becomes y is equal to negative x plus 3. So here the graph should be decreasing, and it has a y-intercept of 3. So you don't even have to say x-intercept at y equal to 0. I'm sorry, the y-intercept at x equal to 0. Why? Because I already know the y-intercept. But say we didn't know. Okay? The learners don't know the theory, they just do the calculations, they know that well. So we then say y-intercept, what do you do for y-intercept? We let x equal to 0. So y is equal to negative 0 plus 3, which is 3. X-intercept, what do you do for x-intercept? We let y equal to 0. So 0 is equal to minus x plus 3. You get over the equal sign, so x equal to 3. So you got the y value of 3 and an x value of 3. Not so? So we can draw again. X is approximately, x will be positive on the right hand side. Not so? And the y will be positive above. About with the same distance from there to there. Why? Because y both is 3. Not so? So what we do is again, we draw the straight line going through. If you want to draw the increments of 1 there, no problem. Okay? Do you see the graph is negative? The graph is decreasing. Negative gradient. You all understand? Yes. You see that your y-intercept is 3. Your c value is 3. You see it's 3 there? Yes. Okay? If the question is to draw the graph, you now don't get marks for your calculations. But you need a calculation to draw the graph. But all your marks are based on this drawing. So if you do all this calculation and you don't draw the graph, you don't get a mark for the graph question. Okay? So keep on practicing, people. Let's look at 15c. Determine the values of the unknown if the points lie on the graph of y equals -1/3 x minus 2. Okay? So remember, when I do the substitution, that's an x and a y. Once I put the input in, I get the output out. Not so? So if I put the x value in, I must get the y value out. If I put the y value in, I must get the x value out. Not so? So what we're going to do is, we're going to substitute -3 and p into the straight line equation, which is y equals -1/3 x minus 2. Now what did I say? This, your coordinates forms an x and a y. So what's your y value? What's your y value? P. P is -1/3 into -3 minus 2. Which gives you an answer? -1. You guys understand? Did you have a problem with this? No. So it's okay by the 1.2. What did you guys get for 1.2? -3. So you're all okay with it, okay? Let's look at number 2. In number 2 it says determine whether the following points lie on the graph. Or the line of y is equal to 2x plus 4. So, if we put the x in, what must we get out? The y. So what I do is I substitute either the x or the y. Okay? I'm going to substitute the x in. By substituting the x into there, if the y value is 4, then what does that mean? If the answer is 4 that I'm going to get out, then what does that mean? That point does not lie on that axis, on that line. It's like having a straight line, or it is having a straight line. This line is going to look like this here. And I plot 2 and 4. You see where 4 is. But by drawing with this point line, this line. But just looking at the drawing with that line. No. But we must not always draw the stuff. We must do the calculation. So if I substitute 2 into x and I get 4 out, which is the y value, then it means to say it lies on the graph. If I get any other value, then what does that mean? Does not lie on the graph. Does it make sense? So what do we have? Y is equal to 2 times 2 plus 4, which is 8. So does it lie on the graph? Therefore, the point 2 and 4 does not lie on the graph. Okay. Let's check -1 and 2. X is -1 here. Y is 2. Yes, that looks like it's lying on the graph. Okay. Again, this graph is not drawn to scale. Okay. So I could be out. I could be wrong. But I think I'm fairly in there. If I look at 2.2, let's check by calculation. We'll substitute x equal to -1. Not so. Then what must the y value be if it's lying on the graph? 2. If it's anything other than 2, then it does not lie on the graph. Where do I get the 2 from? The 2 is the y value. You guys understand? So what do we say? Y is equal to 2 times -2 plus 4. So that is going to give you negative 1. Why am I putting negative 2? 2 times negative 1 plus 4. So negative 2 plus 4 is 2. So is 2 the same as 2? Yes. Therefore, the point negative 1 and 2 lies on the graph or equation y is equal to 2x plus 4. Does it make sense, people? Huh? Any confusion? No? Give the gradient of the line that is parallel to. And perpendicular to the following line. Oh, here's it. Oh, rats. You're going crazy already? But not yet, okay? So, they want to know which lines are parallel or perpendicular. People, if lines are parallel, what do we know? The gradients are equal. Yes, absolutely. So, if lines are perpendicular, then what? Then we can conclude the product of the gradients, of the two gradients, equals negative 1. So first, if lines are parallel, gradients are equal. If lines are perpendicular, then if I take the one gradient, the gradient of the one line, and I multiply the gradient of the other line, it's going to give me an answer of negative 1. Okay? I think we did that when we did the section on graphs. So what is the gradient of this line, of the first line? The gradient here is 2. What's the gradient of this line? Negative a third. So let's look at 3.3. So how do I get it? How do I get to read the gradient? It must be in the form of y equals mx plus c. It must be in that form to read the gradient from it. Not so. So if you got 2y plus 3x equals 6, how do I get that equation in that form? I take 3x over, becomes 2y is equal to negative 3x plus 6. Then what do? Divided by 2, so y is equal to negative 3 over 2x plus 3. So the gradient of this line is negative 3 over 2. Is that correct? Alright. Let's look at 3.4. You got x minus 2y equals 8. Again, get it in the standard form, take it over, negative 2y equals negative x plus 8. Divide by negative 2. So y is going to be a half x minus 4. So this gradient here is going to be negative half. No, it's positive half. So coming back to the question. The question says, give the gradient of the line that is parallel. Is there any lines that is parallel here? Is there any gradients that are equal here? Is there any gradients that are equal, people? No. So are there lines that are parallel? No. Lines that are perpendicular. What does perpendicular mean? The product of the two gradients is negative 1. If I multiply 2.5, what do I get? Positive 1. But what is the condition? It must give you negative 1. So is 3.1 and 3.4 perpendicular? No. There's actually no relation here in terms of parallel and perpendicular. So it's neither. Okay. Was it only 4 sums given? The 3.4 for number 3. So normally they actually give you where you can actually make that link. You can actually see, okay, no, that is parallel, it's perpendicular. But here in this case, for somehow or other, none of it actually works out. Okay? And this is at the end of worksheet 15C. Is that correct? Is there more sums? Okay. I'll show you in. Okay. Determine whether the following lines are parallel, perpendicular, or neither of the two. So again, what's the gradient of this line? -2. But this gradient here, I need to first sort out. Must get it in standard form. Not so. How do I get it in standard form? Y is equal to mx plus c. I must make y the subject of the formula. How do I do that? By taking 4x over and the 6. So it's negative 4x plus 6 divided by 2. So y is equal to negative 2x plus 3. So the gradient here is negative 2. So what can we say about 4.1? Lines are? Why are they parallel? Because the gradients are equal. Do you understand, people? Let's go with a 4.2. Is this in standard form? No. So 4 minus 5y equals x. Take the 4 over. You must make y the subject of the formula. So it's x minus 4. Divided by negative 5. So it's negative 1 over 5x plus 4 over 5. So what's the gradient of this line? Negative a quarter. What's the gradient of this line? A fifth, sorry. Negative a fifth. What's the gradient of this line? Negative 10. Is there any relationship there? If I multiply that, do I get negative 1? No. So is it parallel? Is it perpendicular? So it's neither. No? Is that correct? It's neither perpendicular nor parallel. Okay, we just say neither, it's fine. We go to the next one. X is equal to minus 2 and x equal to 2. If you look at this graph here, x is minus 2. That is the line of x equal to minus 2, not so? It's parallel to the y-axis. It has no y value, no y variable. If you draw this line, x is equal to 2. What do you notice? It's also parallel to your y-axis. So therefore these lines are? Right. Is that the last of it? Yeah. Okay. So people, for homework, the next 4 worksheets, okay? Yeah, this is in preparation of your exam as well. Enjoy the rest of your day and the weekend. Good morning, class.